this is where we end up with today in class. So theorem 11 kind of tells us we can find a basis for a vector space H by beginning with any linearly independent set, and we expand it until we find a basis. And theorem 12 says if V is a p-dimensional vector space, if we have if we have a linearly independent set, there are p elements in it. Because it's p-dimensional, then we know this linearly independent set is automatically a basis for V. And any set of exactly p elements, that if this set spans V, then that set is automatically a basis for V as well. The significance of these two theorems is just shows us how to find basis. So that's pretty much what it does. Now let's take a look at the next statement. This is the fact that you should know. It says the dimension of node A is the number of free variables in the equation AX equals 0. I hope that this makes sense. What is node A? Node A is the collection of all the solutions, right? Solutions of this AX equals 0, this equation. And then now when you write the solution, they always write in terms of free variables, if you can recall, right? Free variables. Therefore, if you have two free variables, your result should be in terms of two free variables. The free variable times a vector plus another free variable times another vector. So therefore, how many free variables, that will be your dimension of this node A. Similarly, the dimension of column A, when you how do you identify the dimension of column A? It's the linear combination of those pivot columns. Column A is linear combination of those pivot columns. So therefore, dimension will be the number of pivot columns. So now let's find the given this matrix, let's find the dimensions for node A and column A. For convenience purpose, I provide this RREF of A for you. So according to what we just had here, how do you find the dimension of node A? You're going to count how many free variables here. Only one free variable. So therefore, the dimension of node A is going to be 1. And what is the dimension of column A? Again, you do see that these three columns are pivot columns. So the dimension of column A is actually 3. So this is pretty much what we just did not get the chance to cover in class.